1 doing question 2. The question 2 says explain the concept functional dependence and explain the various functional dependencies in relational database. So our question has got 2 parts. The first part is the part that says the concept functional dependence. So we are going to explain the concept of functional dependence, and the part B or the other part of the first question to question A state that explain the various functional dependencies in a relational database. So we are going to explain the concept and explain various functional dependencies, which means we are going to explain the types, the various other kinds of functional dependencies. Now, so functional dependencies, these are essential for database normalization, thus organizing attributes. They are vital for design of database schemas, indexing, and also vital for query optimization. So functional dependencies also plays a vital role to differentiate a good or a bad database design. So a functional dependence refers to a constraint between 2 sets of attributes in a relation. So these attributes are in a relation. It specifies that the value of one attribute is determined by the value of another attribute. It also describes the relationship between 2 attributes in a relation. For any relation R, this is the name of the relation called R, containing attributes A and B, and if for every valid instance of A determines uniquely value of B, it is expressed as below. So when we are writing the functional dependence relation, we write the result as A, then an arrow pointing to B. This means that A determines B, or we can say B is determined by A, or we can say B is functional dependent on A. Since A uniquely determines B value, A is determined or identification key, and B is dependent. Now on this example, we see A on the left hand side and B on the right hand side. So every letter or every attribute in the left hand side represents determinant. Now, so on this table, these staff number, first name and surname, these ones are called attributes, and these ones, they Ben, Roy, 2475235 Rango Hogo, are what we call instances or values of attributes. And staff number, first name, surname are the attributes, and these ones are the instances of attributes on the top: surname, first name, and staff number. So example, a relation of employees information. On the below table, we can say first name, surname is determined by staff number. This can be written as staff number, then in forward arrow, first name, add surname. This means that the staff number determines the first name as well as the surname. So we can put the brackets over here to say that staff number determines the first name and the surname. So staff number is the determinant and first name and surname is the dependent, since first name and surname are determined by staff number. So this is the first part of the question A, which says explain the concept of functional dependence. Now we are done with the first part. We are going to the second part, which says explain the various functional dependencies. Now we are going to delve into the various functional dependencies, which are for There are 4 types of functional dependencies, which are: number 1, we have got non-trivial functional dependence, and then trivial functional dependence, transitive functional dependence, multi-valued functional dependence. Now, as per our findings, we have come up with 4 types of functional dependence. Now, starting with the first functional dependent, we have got non-trivial functional dependence. Now, a non-functional dependence is nothing but a dependent not being a subset of the determinant. That is, if X is determines Y and attribute Y is not a subset of attribute X, then non-trivial functional dependence is satisfied. Now, this is illuminated and ambiented better through this example of an employee table with 3 attributes. Remember, employee ID, employee name, employee address, employee name, and employee ID. These are our attributes, all of these 3, and this information is said our attribute is 1530 45 Kali, Chris, Clever, 120 Shashi, 25 Hale, 64 Mabara. These are the instances of the 3 attributes. So it's a 3 by 3 table containing 3 attributes and 3 classes below them. So in the table above, employee ID determines employee name. Employee name is not a subset of employee ID. So in non-trivial functional dependence, employee ID determines employee name. Thus, employee name is not a subset of employee ID, as you can see on the table. That above table we have got employee ID, that's the employee, that's our employee ID, and employee name and employee address is our attributes below their instances. Now we have got employee ID determining employee name. Since employee name and employee address are independent, but employee ID has got a relation with employee name, so we say employee ID determines employee name. Although employee name is not a subset of employee ID, therefore non-trivial functional dependence is valid for such a relation on these 2 attributes. And also we can see that employee ID determines employee address, although employee address is not a subset of employee ID. Trivial functional dependence. Now, a trivial functional dependence is an opposite of a non-trivial functional dependence. By knowing the non-trivial dependence, we can also know the trivial functional dependence, because vice versa is true. Now, a trivial functional dependence, it occurs when the dependent attribute is a subset of the determinant attribute. That is, if attribute B is a subset of attribute A in relationship, then it is considered a trivial functional dependence. For example, a product table with 3 attributes and instances below. Now, in this table over here, you can see that it's a 3 by 3 table. Now, let's see what kind of trivial functional dependence looks like in this table that we are given a product table with 3 attributes. Now, the trivial functional dependence in this table are as below. Now, remember our definition says it occurs when the dependent attribute is a subset of the determinant attribute, which means product ID is also a subset of product ID, since we can see the values of product ID through the product ID. So Product ID determines product ID. Price determines price. Stock determines stock. They are trivial functional dependencies because each attribute is functionally dependent on itself, because knowing the value of an attribute, you can always determine the value of the same attribute. There are also other trivial functional dependencies on this table, which are, remember, it's not only a set of attributes, but it can be a group of attributes determining other attribute or attributes. It's not always the same that it is an attribute determining other attributes or attribute, but it can be attributes or a group of attributes determining other attributes or other attribute. So in this case, you can see that product ID and price determines product ID. Then product ID, stock determines product ID, price, stock determines price, price ID, price, stock determines product ID, product ID, price, stock determines price, product ID, price, stock determines stock. These are considered trivial because they involve an attribute being functionally dependent on itself, or a combination of attributes that include itself thus being a subset. Remember, in this example over here, we have got products, we have in this group of attributes, we have got price in the group of attributes, and stock and product ID. So product ID is inside the group of attributes that are determinant, which means those group of attributes can also determine product ID as the dependent. Now moving on forward to another type of functional dependence, which is transitive functional dependence. Now, a transitive functional dependence refers to a functional dependence that occurs when an attribute is functionally dependent on another attribute through a chain of dependencies. For example, if A determines B, then B determines C, then automatically A determines C is a transitive dependence. The value of one set of attribute determines the value of another set of attribute indirectly. Example given on the below table of employees table, we have got employee ID, name, title is our attributes, and these below are our instances. So the employee ID determines the employee name, the employee name determines the employee title, so the employee's ID determines the employee's title. Employee ID determines employee name determines employee title, then employee ID determines employee title. So on this table, we can see that we cannot know the employee's title unless we know the employee's name. It is not possible to say it is in transitive functional dependencies if we have only two instances or two attributes, but it starts from three or more attributes. Now, employee's ID is not related directly to employee's title, but it is related through employee's name attribute. So we pass through the employee's name to get to the employee's title. So we can say employee's ID and employee's title are related indirectly since we have passed through the employee's name. So employee's ID, by knowing the employee's ID, we can know the employee's name. Then by knowing the employee's name, we can then know the employee's title. So we pass through the employee's name to get to the employee's title. So it starts from employee's ID determining employee's name, then employee's name determining employee's title. So this relation is related indirectly. So if there exists such a functional dependence, we consider that a transitive functional dependence. Now going on forward with functional dependencies, we go to the fourth one, or the last one, which is multi-valued functional dependence. This multi-valued functional dependence occurs when an attribute or a set of attributes uniquely identifies multiple values for another set of attributes. For example, an employee skills table. Here we have got an employee skills table where we have got employee's ID as an attribute, employee's name as an attribute, then employee skill as an attribute, and then we have got these couple of instances below our attributes. Now on this table we have got employee's ID 111, then employee's name Roy, as if we are repeating. It is necessary repetition because on this skill there are multiple or several skills that Roy has obtained. So we can say that in this table the employee's ID uniquely determines the skill possessed by the employee. The employee ID has a multi-valued functional dependence on the skills attribute. So knowing the employee's ID, we can then know the employee's skills, and the employee's skills are not one skill but several skills, many skills. So from the term multi-valued, we can say that the values of the dependent are many as per determined by the determinant. Now, given a scenario where we have got employee ID 1, name Roy, skill Java, or we could have skills being Java only on this other side of the table, where all of these are Java, Python, the Java, all of the skills are Java. This could be an invalid multi-valued functional dependence, because remember, functional dependence, the unique, it's a set of attributes uniquely identifies multiple values of another set of attributes. Now the employee ID should then determine several other dependence on the name. It's only one name on the first employee ID. The name is one, but the skills are many, are multi-valued, are several. So we can say that multi-valued functional dependence is satisfied. Comparing to Adam, she has got several abilities, several skills, and same as to Ben. If we have got Java only here, it would be invalid, but since we have Java, Python, SQL on first employee ID, we have got several, many type of dependent. Going on to the last question, which says state 3 functional dependencies in the following table named assignment M, N, and O are the attributes. Assignment, this is the table where we have got this as our table with attribute M, N, and O, and the question clearly says that state 3 functional dependencies. So our job here is only to state, not to explain, but to state 3 types of functional dependencies. So on this table we have got 3 types of functional dependencies, which are trivial functional dependence, non-trivial functional dependence, and transitive functional dependence. Now to explain this further, to do what we call justice to such kind of a question, we can have a symbol and summary of what we are referring as to trivial functional dependence on this table that we have assignment M, N, and O. Now, with the first one, trivial functional dependence, since a dependent is always a subset of the determinant from the assignment table set M, N, O, where O is a subset proves trivial functional dependence. Similarly, on the assignment table provided set M, N, where N is also a subset proves functional dependence to be true. This can be denoted as M, N, O. These are attributes, all of these attributes. Remember, trivial functional dependence is when the dependent is a subset of the determinant. So we have got M, N, O, and then O is also included here. O is also included inside the set here. So we can say M and O determines O. Same as here, M and M, N is also a subset of the set M, N, a determinant attribute set, group of attributes. So we can actually say M, N determines N. And then moving forward, we can see that there is non-trivial functional dependent, which is an opposite of trivial functional dependence, where we have M determining N, M, N determining O. Since O is not a subset of this set of or group of attributes, and M is not containing any side of it, so we can say M determines N, and then we have got M determining N. N is not a subset, M, and N determining O is not a subset. Then we have got transitive functional dependence. In transitive functional dependence, the determinant is indirectly connected to the determinant. Therefore, from the assignment table, M determines N, and N determines O, and M determines O directly. It is denoted as M determines N, N determines O, then M determines O. Thank you. Thank you very much for listening to me. Have a lovely day further.